Hello everyone. In this video, we will explain what is a SURD, what is a SURD, and what are the types of SURDs, and what is a rationalizing factor, and what is the conjugate of a SURD. So these SURDs are very useful to understand sometimes certain angles in trigonometry, like sine 36, sine 72, cos 36, etc. Not only that, in solving of many questions, you can see the value of a surd, square root of a surd, cube root of a surd, etc. So, what is a surd? Here you see real numbers. Real numbers consist of only two kinds of numbers. Every real number consists of only two kinds of numbers. One is rational number. Rational numbers, and other one is irrational numbers. So real numbers can be divided into two categories. One is rational numbers, other one is irrational numbers. So rational numbers in the form of p by q, okay, where p comma q belongs to z. Of course, q not equal to 0. Irrational numbers, those numbers not in the form of p by q. Okay. Here, those numbers not in the form of p by q. These are the irrational numbers. For example, some irrational numbers are like this: root 2, root 3, pi, e, etc. So these are all irrational numbers. So here, surd is the part of irrational numbers. Surd is a special case of numbers which comes under irrational numbers. So surd is some special numbers comes under irrational number. So surds are some special cases of irrational numbers. For example, you take that root 4 equal to 2. So it is a rational number. Okay, so you can write belongs to Q, rational number. Root 9 equal to 3. It is also a rational number. Well, so surds are some special cases of irrational numbers. Now root 2 is a surd. Root 2 is a surd. Cubed root of 3 is a surd. Cubed root of 3 is a surd because it is an irrational number. So surds are part of irrational number. Is a surd. Like this fifth root of 4 plus 1 is a surd. Is a surd. So how do we define a surd? Here root 4 equal to 2 is not a surd. Root 9 is equal to 3 is not a surd. Or even you can say that cubed root of 27. So this we get is not a surd. It is a rational number. It's not a surd. So a surd is in the form of that a to the power of 1 by n. A surd is in the form of a to the power of 1 by n. Here you see this is 2 to the power of 1 by 2. Here you see this is 3 to the power of 1 by 3. Here you see this is 4 to the power of 1 by 5 plus 1. So our surd must be in the form of a to the power of 1 by n, where a is a positive rational number. Where a is a positive rational number. So if a greater than or equal to, if a is a positive rational number, then a to the power of 1 by n or nth root of a, where of course n belongs to n, is called a surd. Of order n. So if we take n equal to 2, then it is a surd of order 2. If you take n equal to 3, a to the power of 1 by 3, then it is a surd of order 3. If you take n equal to 4, it is a surd of order 4. So if a is a positive rational number, then a to the power of 1 by n or nth root of a, n belongs to n, is called a surd of order n. So if a is a positive rational number and n is a positive integer, such that nth root of a, that is a to the power of 1 by n, is an irrational number, which means that a to the power of 1 by n should not be a rational number. Then a to the power of 1 by n is called a surd. So for example, we have taken that root 2, root 3, or you can say 5 to the power of 1 by 4, or 7 to the power of 1 by 8, etc. are all surds. Remember here, a must be a positive rational number. So I will give you one example which is not a surd. This is square root of pi, square root of e, are rational or irrational numbers but not surds, or irrational numbers but not surds. They are not surds because here the pi is a special kind of irrational number. It is an irrational. And we cannot express this is nth power of some rational number. It cannot be expressed as nth power of a rational number. It cannot be expressed as this is nth root of a rational number. Nth root of positive rational number. Well, so now I'll provide some special cases of these surds. Okay, here you see a to the power of 1 by n is called a surd of order n. So here you see square root of 3 is a surd of order 2. Is a surd of order 2. This is known as a quadratic surd. Quadratic surd. And if you take that cube root of some 5 is a surd of order 3. So this is known as a cubic surd. A cubic surd, etc. So what are the types of surds? Here you see pure surds. So what is a pure surd? Pure surds, a surd having no rational factor other than unity is called a pure surd. Having no rational factor. Having no rational factor other than 1. You see, here this is root 3. Root 3, it is just 1 into root 3. It has no other rational factor other than 1. In similar way, you take that cube root of 3. It has also no other rational factor other than given surd. So these are the pure surds. Now, what are the mixed surds? Here you say mixed surds. Surds having a rational factor other than unity. Here having no rational factor is a pure surd. Having a rational factor, for example, 2 into root over 5. So this is 2 into root 5. This is the rational factor. Rational factor. So it is a mixed surd. It is a mixed surd. Or you can say root over 12. Root over 12. Even though it seems to be like a pure surd, but it's not exactly, because we can write this as root over 4 into 3. So this we get 2 into root 3. 2 into root 3. So it is a rational factor. So 2 is a rational factor. So mixed surds are the surds in which they must have a rational factor other than unity. Like you can take root over 75. Root over 75, I can write root over 25 into 3. That's equal to 5 into root 3 is a mixed surd. Is a mixed surd. So pure surd means it should not have any rational factor other than 1. Now, what are the monomial surds? What are the monomial surds? A surd containing only one term is called a monomial surd. A surd containing only one term is called a monomial surd. So here you see only one term is there. So these are the monomial surds. Here I can write one example because you must know the difference between pure surds and monomial surds. Here I can write that root 7 plus some 3. It has no rational factor other than 1. It has no rational factor other than 1. Or I can write cube root of 9 plus some 2. It also has no rational factor other than 1. So those are it. So the difference between pure surds and monomial surds is, in monomial surd, you must have only one surd. Monomial surd means it must have only one surd. Not only this, I can write some other examples, like you can say cube root of or square root of 27. So this I can write further 3 into root 3. It has only one term. It has only one term, but it's not a pure surd because it has a rational factor 3. Okay, so it is a monomial surd. So binomial surds means an expression consisting of sum or difference of two monomial surds. Two monomial surds is called a binomial surd. Or sum of a monomial surd and a rational number is also called as binomial surd. So binomial surds means bi means it must have two terms. So here the meaning of bi means it must have two terms. So bi means it is two. So binomial surds means it must have sum of, it must have two monomial surds or one monomial surd and other one is a rational. So you can find examples here, 2 plus root 3. So this is a rational. 2 plus root. So this is a rational. Okay. And this is a monomial surd. Right? Or you take this, this root 5 minus root 3. So this is a monomial surd. Okay. And this is also monomial surd. So it is the difference of monomial surds. And this is sum of two monomial surds. So such surd is called a binomial surd. So binomial surds means it is a sum of two monomial surds or a sum or a difference of one monomial and one rational. What are the trinomial surds? So here tri means three. Tri means it is just three. So tri means it must have three monomial surds. So an expression consisting of three terms of which at least there must be two monomial surds. At least there must be two monomial surds. If only one monomial surd is there and other one is rational, then it is a binomial. So here I can write an example. Root 2 plus root 3 minus 1. Right? So it is a monomial and rational. So it is a trinomial surd. It is a trinomial surd. So this is a monomial. This is also monomial. And this is a rational. Or you can take cubed root of 3 plus cubed root of 9 plus square root of 2 is a trinomial. It is also a trinomial surd. Because here we have three monomial surds. So here, what is a mixed or compound surd? Mixed or compound surd is a surd sum of one surd and one rational number, right? So only the name is different here. So mixed surd or compound surds. You may think like that. You see 7 by 3 can also be written as 2 and 1 by 3. So 7 by 3 can also be written as 2 and 1 by 3. So 2 and 1 by 3 is known as a mixed fraction. A mixed fraction. Similarly, if a number is made up of rational part, rational number, irrational part means here, my meaning is only surd, is called a mixed surd. So the general expression is like this, a plus or minus b root c. So for example, one example I can write here. You take that 1 plus 2 into root over 3. right? So is a compound surd or a mixed surd? Why do we call it is a mixed surd? It is the sum of one rational number and one surd, or 2 minus cube root of 3 plus fifth root of 5. So this part is nothing but this is entirely a surd and this is a rational. So a sum of rational and a surd is simply known as a mixed surd. So what is a similar surds? When we say that two or more are said to be similar surds. So similar surds means two surds are said to be similar surds if their radicands are equal. This A is called a radicand. And this root is called a radical. Okay. If the radicands are same, that is A equal to B. In other way, two surds are said to be similar surds if their ratio is a rational number. If their ratio is a rational number. For example, here you take that 3 root 5 and root over 125 are similar surds. Are similar. Why they are similar? If you take the ratio 3 root 5 by root over 125. So this is nothing but 3 root 5 by. This is 25 into 25. 25 into 5, sorry. So I can write this is 5 root 5. Okay, cancel. It is a rational number. So if the ratio of two surds is a rational, then those two surds are said to be similar surds. But if we have more than two surds, so that's why you see they must have same radicand. They must have same radicand. So here you see minus 3 root 6, 8 root 6 are similar surds. Because if we combined them, means if we add or subtract, then it will be reduced to a single surd. It will be reduced to a single surd, right? So, or you can take like this also. For example, 5 root 8 plus 3 root 8 minus 4 root 8, right? So this is equal to, you see, it becomes 4 root 8. So if their radicands are same. So here I have given an example. Here you see that 5 root 8 plus 3 root 8 minus 4 root 8 reduces to a single surd. So therefore 5 root 8, 3 root 8, 4 root 8 are similar surds, or you can say like surds. The above one is only for quadratic surds. You see here, I have written two quadratic surds. But it is not necessary that every time we must have quadratic surds. So two or more surds are said to be similar or like surds if they have same irrational factor. If they have same irrational factor. For example, 5 into cube root of 3. 2 into cube root of 3. 11 into cube root of 3. Minus 4 into cube root of 3. See, they all have same irrational factor. So these are all like SURDs. These are all like SURDs, or you can say similar SURDs. And if they do not have same irrational factor as a common, then they are said to be unlike SURDs. Okay. So here I'll write an unlike SURDs. For example, 5 into cube root of 3, some 6 into square root of 2 are unlike SURDs. They are unlike SURDs. Now two more concepts left. That is, what is the conjugate SURD and what is a rationalizing factor. So what is conjugate SURDs and how do we define a conjugate of a SURD? It is a very, very important one. Conjugate SURDs. So here you see two SURDs are said to be conjugate of each other if their product give rise a rational number or a non-SURD, right? Simply, you can say that 2 plus root 3, right, is a conjugate of, is a conjugate of 2 minus root 3. Because since 2 plus root 3 into 2 minus root 3, 2 plus root 3 into 2 minus root 3, this you will get that 4 minus 3, this is equal to 1, right? So here you see that two SURDs are said to be conjugate of each other if the product gives rise a non-SURD. In other words, the product is a rational number. The product is a rational number. So what is the conjugate of a plus b root c? So the conjugate of a plus b root c is a minus b root c, right? Which means that only there will be a sign change in the SURD only, not in the case of rational number. So the conjugate of this is another SURD which is same as the above SURD with a difference in their signs. In other words, the conjugate of a plus b root c is a minus b root c, but not minus a plus b root c, but not minus a plus b root c. So the conjugate of 2 plus root 3 is 2 minus root 3. You have to change the sign here only, not before the rational number. Not before the rational number. Rational number will always remain same. Rational number will always remain same. So to sum it up, conjugate of quadratic compound SURD having in general expression like this. So the conjugate of root a plus root b is root a minus root b. Because if you multiply these two, you will get the product is simply a minus b. Well, here some a is missed. And the conjugate of a plus a root b plus c root d is a root b minus c root d. So the conjugate means simply it differs in sign and the product must be a rational. So once again, I'm writing here the conjugate of some a plus root b is a minus root b. Here a is a rational. A is a rational. And root b is a SURD. Root b is a SURD. The conjugate of for example, 2 minus 3 root 5. So what is the conjugate of this number? You just change the sign here. You write 2 plus 3 root 5. This is the conjugate. Or I can give another example, the conjugate of some root over 3 plus root over 2 is you can keep the minus sign either before root 2 or before root 3. Either before root 2 or before root 3. Or you can write root 2 minus root 3. Either of these two are the conjugate of root 3 plus root. Now one more concept is left, that is the rationalizing factor. So what is rationalization? When do we use this rationalization? Rationalization is a method of simplifying a given surd when it comes in specifically denominator. So to reduce the denominator surd into rational and a numerator into surd is known as a rationalization. So a rationalization is a method of simplifying a fraction having a surd either as its denominator as both numerator and denominator such that it can be rewritten without a surd in its denominator. Without a surd in its denominator. For example, here you say 1 by 2 plus root 3. It is a given surd. Now, we have to reduce this 2 plus root 3 into a rational number. So, we have to multiply both numerator and denominator by its conjugate. 2 plus root 3 into 2 minus root 3. So that we get this is equal to 2 minus root 3 by denominator is 1. So, this process is known as a rationalization. So, in rationalization, simply we'll multiply both numerator and denominator by conjugate of numerator or conjugate of denominator. There are two cases. See, here the rationalizing denominator often takes the two following forms. A by root b is given. A by root b is given. Multiply numerator and denominator by root b. So that now you see the denominator reduces to a rational number. 1 by a plus root b is there. So multiply by its conjugate. Multiply by its conjugate. So what is the conjugate of a plus root b? A minus root b by a minus root b. That we get a minus root b by denominator is a square minus b. This is a rational number. So rationalizing of denominator is there. Rationalizing of numerator is also there. Sometimes they ask rationalize only denominator. Sometimes they ask rationalize only numerator. These all kind of questions comes in limits also, calculus. So here you see 1 by a root b plus c root b. So for this multiply both numerator and denominator by its conjugate. By its conjugate. By its conjugate. So what is the conjugate of this? Okay, here I'll write that 1 by a root b plus c root b. We want to rationalize this. Multiply by conjugate of denominator a root b minus c root d whole by a root b plus c root d into a root b minus c root d. Now it reduces to, here you see, this gives us, this is equal to a root b minus c root d. Denominator is x plus y into x minus y. So you can write a square b minus c square d. Assume that a square b minus c square d is not equal to 0. So this is the rationalization method. I'll give you an example on this rationalization method. One example, rationalize denominator of 1 by 7 minus root 6, for example. Right? So here is the answer that 1 by 7 minus root 6 equal to, multiply numerator and denominator by its conjugate, 7 plus root 6 by 7 minus root 6. This is equal to 7 plus root 6 by, it is multiply with the numerator and denominator by 7 plus root 6. Denominator is a plus b into a minus b. So you will get 49 minus 6. That's equal to 7 plus root 6 by 43. I'll give you another example. 1 by root over 1 plus x squared plus 1. So we have to rationalize it, right? So root over 1 plus x squared minus 1 by root, directly I can write 1 plus x squared, simply whole square. No, there is no whole square. This is minus 1. This gives us 1 plus x squared minus 1 by simply x plus x squared. So in the next video, I'll solve a few questions based on this SURDS.